Welcome to our session on Azure Data Factory and Bicep. My name is Benjamin Kettner. I'm CTO at MLPA in Berlin, Germany. I'm very happy to be presenting today with Alpa. Alpa.
Hi all, thank you and welcome to our session. My name is Alpa Buddhabhatti and I'm working as Azure consultant at Cluster Reply UK. And I'm here to share my knowledge with Azure Data Factory. So let's start with today's agenda. So today's agenda is divided into 6 main parts. So let's start with first one, Azure Data Factory. So Azure Data Factory is a cloud-based data integration service that orchestrates and automates the data movement and data transformation at scale. It is also Azure Platform as a Service and it's a serverless. Because of these two reasons, you don't need to worry about software installation, web server configuration, operating system, or implementing your monitor tools and many more things. Azure will do it for you. So you can fully focus on implementation and you can build it very quickly. And because of these two reasons, you only pay for what you have used. For example, you have Azure Data Factory and you have 100 pipelines there. However, pipeline is not running, then you won't get any charge for execution. But you get small amount of charge for storage, which can be negligible. And last but not least, it's a low code or no code solutions. So you can very quickly build your pipeline by just drag and drop components. And you not just build your pipeline, you can uh, orchestrate your pipeline, you can automate your pipeline, you do data movements and data transformation all by just drag and drop. And you can do it very quickly. And it's a cost effective as well. So this is Azure Data Factory. Now let's see what can you do in Azure Data Factory so you get idea why you need Azure Data Factory. First one is copy data. You can copy data using two way. You can use a copy data tool or you can use a pipeline and your pipeline have a copy activity. So for that you can select your source. So your source can be like other cloud service, for example AWS or Google Cloud. Your source can be from on-premise system, for example, SQL Server, Oracle Server, or SFTP. Your source can be like SaaS system, Salesforce and CRM 365. It can be like custom activity like Azure Function, HTTP web call, or REST API, and many more. So these are the sample source you have. You select it and then you set few properties in your copy activity settings and you can have move your data in the same data source or different data source. And these are the sample data sources here in right side. So this is a copy data which you can move your data from one source to another source. And in Azure Data Factory, there are around 100 data sources available which you can use as a source or as a sink or both of them. And this is a link which help you to find out more information regarding your source and sink data sources. And this is called a data movements. So using Azure Data Factory, we can do a data movements, and data movements is a very important part in your modern data warehouse or ELT or ETL. So this is a data movements. Now let's move into next. What else you can do in Azure Data Factory? So you can do a data transformation. For data transformation in Azure Data Factory, there are mapping data flow is available, and behind the scene, it's used the Spark cluster. So without writing a code in a programming language like Scala, Python, and Java, you still can get same features by just drag and drop components using Azure Data Factory mapping data flow. So you first select your source. So this is a sample source. Then you apply here aggregation. You can join two different data source. You can use do union. You can add new columns. You can calculate columns. You do so many things here by just a drag and drop. And then you select your sink and it's move data into your sink. So this is called a data transformation using Azure Data Factory. And same thing you can do it in, for example, SQL language. So you do like big queries, you do group by, you do aggregation, you do add new columns, you apply union, those all things you can do it here by just a drag and drop, and you can do it very, very quickly as well. So in Azure Data Factory, for mapping data flow, there are around 18 data sources available, which you can use as a source or as a sink or both of them. And again, this is the link which help you to find out which data source you can use as a source or as a sink or both of them. If your source is not available here, then you can use commonly used data sources. For example, Azure Blob Storage or Azure Data Lake Gen 2. And this is called a data transformation. And data transformation is a very important part in a modern data warehouse, and you can use in ELT or ELT as well. So now let's move into next one. So when you create your components in Azure Data Factory, behind the scene is generate a code, JSON code. However, you don't need to worry about it at all because it's ready for your source control and is automatically generated by Azure Data Factory. And this code you can use for your CI/CD pipeline for continuous integration and continuous delivery. It also provides you a Git integration built in. So using the UI, you can set up your repository by just a few buttons clicks away. And you have a two different kind of repository you can set up. You can use Azure DevOps Git or you can use a GitHubs. It easily allow you to monitor your resources using the Azure Data Factory UI, and it allow you to manage your resources, Azure Data Factory resources using the UI very quickly and very easily. And last but not least, you can do trigger your pipelines as well. Those all things you can do it using the UI. So now let's move into next topic, which is what are the key components of Azure Data Factory. So there are five main components of Azure Data Factory. So let's start with first one, which is a linked service. So linked service is similar to a connection manager in SSIS. So linked service hold the connection string. It's authorize your data source. So your data source can be used by other components in your Azure Data Factory. Next one is datasets. Datasets represent metadata of your data or reference of your data or a structure of your data. So it can be in a form of a table, file, or a folders. So for example, if your link services is pointing to a Azure SQL database, then your data sets in form of a table. But if your link service is pointing to a REST API, then your data sets in a form of the JSON file. Next one is activities. Activities do a specific task in Azure Data Factory. So if you compare with any programming language like C Sharp or a database language like SQL Server, then you know that you are writing a logic like you have for each loop, you use declare variables, you do some joins, but you're writing a code. But in Azure Data Factory, as it's a no code or low code solution, you are not writing a code, but you have a components for that, which is activities. So each activity has a specific purpose. So it has a copy activity, it has a if loop activities, it has a for each loop activities, and many more. So here are the few examples. So instead of writing a code, you just drag and drop these components, which do a specific task, for example, for each loop. Next one is a pipelines. Pipelines is a logical group of your activities. So it has the sequential or parallel steps of which achieving the outputs. So your pipeline can have like one components and another components, and it has like output of one component to input of other components, and they can be in parallel or a sequential. So in this example, you can see that output of one activity is input of another activity, so they are a sequential. And here you can see that output of these two activities, which is in parallel, and it's input of next activity, and here is a sequential as well. So this way your pipeline is designed which achieve a specific business requirement related outputs. And once your pipeline is ready, fifth components comes into picture, and you need to run your pipeline. So for that, you can use a debug your pipeline, or you can use a trigger your pipeline. And you can trigger it various different way. You can trigger it based on a specific times. You can trigger this based on when file arrives or in your blob storage, or when file deleted from your blob storage, or you can write down your own codes. You can write down your codes in C#, or you can use Azure function, you can use Azure Logic Apps, you can use PowerShell, or you can use Event Grid as well. So these are the 6 components of Azure Data, 5 components of Azure Data Factory. Apart from that, there is one is available, which I'm going to show you during the demo. So now let's move into Biceps. So I would like to hand over to Ben for that.
Okay, thank you, Alpa. So now when we're starting to talk about Bicep, then the first thing I would like to answer, the first question I would like to answer is, what is Bicep after all? What is it for? And that's pretty simple to answer. Bicep is a domain-specific language. It's a language that you can use to deploy, declare, and then deploy Azure resources. So basically what Bicep does, it defines your infrastructure, your Azure resources as code, and enables you to deploy those. So this might seem a bit contrary to what Alpa said about being able to drag and drop all the components in Data Factory, because actually we do not want, when we talk about Bicep and we talk about infrastructure as code, we do not want to drag and drop. We want to write code, and we want to source control our code, and we want to work with code and use all the nice tools that we get for working with code to declare resources. And today we will show how you can define resources in Bicep, but not only resources in Bicep, but also the resources within a Data Factory in Bicep, which comes at some with some benefits. Now, many of you might think, okay, I've heard a lot about ARM templates before in Azure, and I thought ARM templates were the domain-specific language for declaring and deploying Azure resources, and that's also true. However, Bicep is an improvement over ARM, and it's possible to decompile ARM templates to Bicep templates and compile Bicep templates to ARM templates. So they are within certain limits interchangeable. And Bicep has some advantages over ARM. The main advantage being that ARM is very verbose and Bicep is much better readable. And you'll see some of that when we go through some code later on. That means that Bicep is much easier to develop than ARM because it's easier to read and easier to write. And what's really nice, Bicep has really good Visual Studio Code integration. There's a good plugin for Bicep in Visual Studio Code that you will also see in action later here in this session. But now, if we can click and drag and drop everything, why would we even want infrastructure as code? Well, there's several reasons for that. The first one is it's controllable. We're all humans, we all make errors. We all make mistakes when creating resources. We all make mistakes when dragging and dropping. And having some sort of code that I can version control, that we can have code reviews on, and that I can use in pipelines gives me the possibility to audit my developments. It gives me the possibility to see a history of the changes of my development. And that's most important, it's repeatable. So assume you have a solution that's not a data warehousing solution, but any other solution that needs to batch process data. And you have a dev, test, and prod environment, and you want the pipelines to be the same in the dev, test, and prod environment. And let's just assume that there's more than one pipeline, more than one data source. You would need to drag and drop, click and type lots and lots of developments in 3 stages, or three stages. So having that in a form of code makes the deployment repeatable. And if you make a mistake, this mistake will be present in all stages and not only in one stage. So what you did will be the same on each stage. Furthermore, you can, if you have infrastructure as code, it's much easier to enforce, for example, naming conventions. And naming conventions are a nice thing because naming conventions help us to find our resources and understand what they were created for, because they have a name that somehow speaks and adheres to some convention. This reduces errors, and furthermore, it helps you with disaster recovery. If one Azure region goes down and you want to have the same data factory with the same pipelines deployed in a new region, having everything as infrastructure as code will help you to pull up the same environment within minutes. And finally, infrastructure as code is also a form of documentation. Having your infrastructure as code with commit comments that don't only say commit 1, commit 2, commit 3, but have meaningful commit comments helps you document your development and understand what you're trying to do with your development. So all of these are reasons why infrastructure as code is a good idea and why Bicep is a good idea. And now with the strength of Azure Data Factory that Alpa already mentioned, combined with the strengths of infrastructure as code and Bicep that I just mentioned, we will see that these two make up a very good pair for building your data pipelines and for controlling your data pipelines and for creating repeatable data pipelines. So what will happen now is we'll switch over to demo mode. Alpa will show you the creation of different parts of different components in Azure Data Factory. And then I will show for each part how these components are created using a Bicep template. So you will see both. You'll see how they work, where they are similar, where they're different. And in the end, you will have a good overview over Data Factory and over how you can create resources within Data Factory from infrastructure as code. So Alpa, please take over and share the first component of Data Factory.
Yeah, thank you. So this is our resource group. And in our resource group, we have around 5 different resources. So this is Azure Data Factory. This is SQL Server. This is Key Vaults and block storage. So let's start with the first one is a Key Vault. So we have used a Key Vault to store our secrets here. And this Key Vault has 2 secrets. One is a blob storage access key and one is a Azure SQL Server connection string.
And maybe, Alpa, we should mention here that this is absolutely best practice. You should never store your connection strings anywhere but in a Key Vault.
Yeah, absolutely. Yeah. So this is the best practice. There are 2 main reasons. One is a security and another thing is a central place. So if you have 3 different or more than one systems you have and you're using same connection database and connection sync has changed tomorrow, then you don't need to go to each system and change connection sync. You can only change in central place and all other system will use that one. So that is another benefit. So this is the good best practice as Ben said. So this is a Key Vaults. Now let's go back what else we have in a resource group. So we have blob storage, which store the source file, and we are moving our file from source to sink. So our sink is Azure SQL Server, and just going to show you, we have a file in here. This is movie DB file, a CSV file, and then we have the Azure SQL Server, which hold the sink data. And this is Azure Data Factory. Let's open Azure Data Factory. So this is Azure Data Factory looks, and you need to click here. So it's launch studio for Azure Data Factory. And here you can do so many things as well. You have ready-made tutorials and videos as well, which help you to find out more information about Azure Data Factory. And here are 3 main components. So first one is Manage tab, which allow you to manage resources here. For example, link service, integration runtime, or you can have a Git connection or ARM templates as well, and many more. So for our demo, we are creating link service here. But before that, I just would like to quickly show you more things in here. So this is a Manage tab. And this is a Monitor tabs. So here you can monitor your pipelines and many things like triggers, integration, runtime, debug flow as well. At the moment, we haven't run anything, so you are not able to see here, but you can see it here. And here you can create your pipelines and data flow and data sets. So now let's create a link service. So we have already created link service here, but I would like to show you how you can create your link service. So these are the sources available. As I mentioned, there are around 100 data sources available. So these all are sources. So you need to pick your source first. So our source is a blob storage. So let's just select our source and click continue. You can give here suitable name. I'm just keeping as it is. You add a description if you like to add, and here you select your integration runtime. So this is the 6 components, as I said earlier. It's compute infrastructure. As we said earlier, it's a platform as a service and it's serverless. But however, to run your pipeline, you need a compute infrastructure, and that is a integration runtime. So there are 3 different kind of the integration runtime. So by default is auto integration runtime, because if your source and sync on a public internet, then you can have a auto integration runtime, which is a default as well. But if you are using SSIS package, then you can use a SSIS integration runtime. And if your source or sync anyone of from on-premise system, then you can use a self-hosted integration runtime. So I'm using this by default one, but you can create here quickly as well. It's a few button clicks away. If you want to click create new one, then. And here is authentication type for selecting source, and you can select manually as well, but we would like to select it from key vaults. And here we're going to select a key vault's name, and it will automatically give you secrets. So we are creating for blob storage. So that's
Maybe
it.
we should mention, Alpa,
Yeah.
sorry to interrupt you, but we should mention that the secrets will only show up here if you have given
Access
your
policy.
data factory permission to read the secrets by setting an access policy in the key vault.
Yeah.
This is an important step because this is a source of lots of frustration with many customers who say, okay, the secrets don't show up, something's wrong.
Yeah,
so this is really important. This is an important step that we just skipped.
yeah, that's absolutely right, Ben, because I can show you them now. That if you want to your Azure Data Factory access your key vault, then you need to give a access policy here. Like Ben mentioned, that this is the one, otherwise you're not able to find secrets from key vaults. So you can see that I have here my Azure Data Factory, and I have given secrets select permission as well. And you can easily add at access policy by just clicking here. It's a few button clicks away. You just select permission and select your Azure Data Factory. That's it. So this is a very important step, like Ben mentioned it. And here you need to type your Azure Data Factory, because I have already given my Azure Data Factory, but you need to select your Azure Data Factory like this way. So you will type here your Azure Data Factory name and you will select it. That's it.
If you have sufficient permissions on the Active Directory of the tenant, then this will also autocomplete.
Yeah, that's correct. Yeah. So that's it. You select here and you click on it. That's it. So this way you're giving your Azure Data Factory to access key vaults. Otherwise, you won't able to see here secrets. So this will automatically comes here once you have a permission. And then you can click on test here. So that's it. So this way you create your link service. And this way now your your data set can easily access blob storage without saying which blob storage, because it's using this link service. So
now let me show you the same thing in Bicep.
Yep.
So what you will see now, as we've already said, is some code in Visual Studio Code. And so I will take over the screen from Alpa and show some code. So welcome to Visual Studio Code. This is a Bicep file, and the simple basics are you have parameters that you can or need to set when you deploy your template. Parameters can have defaults. You can define variables, that, for example, use functions, unique string functions, for example. And then you can have resources. So let's go through this template step by step through the first few things that you just saw in the Data Factory UI and what that looks like in Bicep. I would just like to mention that usernames and passwords should never be variables. That's only for demo purposes here. They should be parameters without default values, and you should have to set them when deploying your resources. Here, for ease of use, I just made them variables, but do not do that. Do not try that at home. Okay, so the first thing I want to do is I want to use Alpa storage account. So I define a resource. I call it storage account, and it's of type Microsoft storage accounts. I have to give an API version, but don't worry. Usually you don't have to worry about that. The extension also helps you to complete that. And since I want to reuse Alpa's storage account, I can say existing and just give a name. And the name here is a variable. So this is Alpa storage account, and I just use the existing storage account here. Same for the SQL Server. I just use SQL Server's existing and give the SQL Server name. And for the SQL database, and now you see one nice thing about the Bicep extension in Visual Studio Code. For example, I get a warning here denoted by this squiggly yellow line that for some reason I decided to declare that SQL database, but I'm never using it throughout the script. So the Visual Studio extension is telling me just get rid of it. You don't need that for what you're trying to do here. So I could just get rid of that without any changes. Now let's not only use existing resources, but declare new resources. So I would like to create a key vault. If I want to create a key vault, works the same way. I prefix with resource. I give my resource an internal name. This can be any name. It doesn't matter. So this is not. This is just a name that I can reference it by throughout my template. I tell Bicep what I want to create. I want to create a key vault with the 2021 preview API. And then I have to give some parameters. For example, a name. I can set tags. I have to give a location. And I can do something. I can set access policies. And that's a nice thing because from creating the key vault, I cannot forget to set the access policies if I create it that way. So what we just pointed out, what you have to do when you do this manually, if you do this through Bicep, this is done automatically. So I just set an access policy. I reference Data Factory and just say, give me that identity, and it gets permissions to get and list the secrets. And that way, when the template is deployed, this policy will automatically be deployed together with my key vault. And that's quite nice. And then the next thing that I need to do is what Alpa just showed you is add the secrets. So you can see the type is Microsoft Key Vault's secrets. Add the secrets with the storage account secret name to the key vault and give it a value. So set the connection string. Same for the database. And now I can create a data factory and just say, okay, my data factory has a name. That's also in a variable again. It has some tags, it has a location, and it has a system assigned identity, which is the identity that was referenced here. And what Bicep does under the hood when you deploy that, it notices the order in which resources need to be deployed. It doesn't go from top to bottom, but it knows the dependencies from each other. And it knows that if I want to set this access policy, I need the identity for the data factory, and that means I need to create the data factory first before I can create the key vault. And Bicep handles all that for you. You don't have to care about that. You just declare what you want to have, and the whole Azure templating Bicep engine does all the dependencies and all the order of deployments for you automatically. Okay, so with these lines of code, we will be able, and we'll see that in the end, to create a key vault, add 2 secrets to the key vault, create a data factory, and give the data factory access to those 2 secrets. And I think this is the syntax with which this is written is very descriptive. It's very easy, and it's very easy to read. And another thing about the Visual Studio Code plugin, if I remove the name here, you can see I get red wiggly lines here, and it tells me specified resource declaration is missing the following required properties name. So it tells me that I have to set a name for my resource, which somehow makes sense if you've worked with Azure before. But I get that kind of information automatically, and I also have autocomplete. So it tells me what I can do here. So I can say, okay, depends on, if I want to set dependencies manually. Usually this is not required. And I can set the name. So basically, this is what the Visual Studio Code extension that's really good looks like and works like, and how we create a key vault with 2 secrets. And the nice thing is secrets from existing resources. So the storage account ID is the ID of the storage account that Alpa deployed previously. So this is not something that I need to set in my Bicep template. I just reference it and create a data factory. And now the linked services. So the first thing that we need to create is a linked service for the key vault. So let's now create a linked service for the key vault. As you can see, the type is data factory, factories, linked services. The linked service, again, has a name. I've given the dependency explicitly, saying it depends on my data factory, because I can only create the linked service in the data factory if I have the data factory. And the properties is that the type of this linked service is Azure Key Vault, and the base URL is the URL I get from the properties of my Key Vault resource. The same way I create a storage account, and it's of type blob storage, and the connection string is a Key Vault secret, and I give the name for the Key Vault and the name for the secret. And the same, of course, for the database. And that way I've created the 3 linked services that you saw in Alpa's data factory. So Alpa, let's talk a bit about datasets.
Yeah. Okay, let me share my screen. So yeah, here you can see the 3 linked service like Ben mentioned as well. So this is Key Vault 1. And behind the scene is generates this JSON code. As I said earlier, you don't need to worry about it at all if you are new to JSON code. And this is a Azure SQL Server related. So you can see here as well, we are not specifying a connection database name or server name or anything. We're just using secrets. So it's very secure as well. Okay.
Maybe we should also mention that the JSON code that is generated is ARM code. So these are ARM templates that are created under the hood. And so that's also, if you're unsure how to create the Bicep for a certain resource, you can create it in a data factory, have a look at the JSON, and then you'll get an idea of the keys and of the properties you can set.
Yeah, absolutely, yeah. And here you can see that who is using your link service as well. So if you would like to change your something like data set, or you would like to delete your link service, then you first need to remove the reference, whoever using. So that is the one link service now. So I would like to show you now how you can create your data sets. So for that, you need to come into author tab. And here you can see that there is a section data sets. And here you can see that you can have these 3 dots. It's here, and here you can add, like you can create your data sets. So let's create new data sets. And here, these are the sources available, which we can select as a source or sink. So let's see, our source is blob storage. So we are creating a data set of a blob storage. And our file is in, I think it's a CSV file. So we are selecting format CSV. And these are the formats Azure Data Factory allow you to select of a file types. And if your format is not available, and if your source and sink both are in so if you use binary, then you can move your file. Even you can move your image file or your zip file or any file, you can move it. But then you have to select binary format. And at that time, you have to select your source and sink both type as a binary type. So you can give here suitable name. I'm just keeping as it is. And here we are selecting a link service because we only and only access our source via the link service. So we have already created these two, one which I already had and one we have recently created. And here we are selecting the container name. So this is our container name. And we even can select our file name, and we can parameterize it as well. But let's select a static one, file name. And our file has a header. So that's why we're selecting here. And our schema should come from our file. So that's why I'm using this one. You can have a sample schema as well. If you separate file, you can load that as well. And you can choose none as well. Specifically, you do none when you have creating data set for your sync. So this way you create your data sets, and you can rename here. You can see who is using your data set as well. You can see JSON code by clicking here. And here you have so many other things. Because in CSV file also you have some variation, then you can say that it needs escape character or quotation or like row or column delimiter. You can change here that as well, and you can say null value as well. So this is your data sets. You can create it. So I have created only one data set, but we need two data sets because one for blob storage and we need one for our sync, and our sync is a SQL server. So I can show you that quickly how you can create another data set as well. So let's create new data set for SQL server, which is very similar to what we have done so far. So we are selecting here database.
And I strongly recommend that for any purpose that goes beyond demos that we're doing here, to use the folders to structure your data sets and pipelines, because this will get really messy after a time.
Yeah, absolutely. Yeah, I will show you here how you can create folder as well. So this way you just select it. It's absolutely same way we did earlier as well. You can select your table name as well, or you can keep edit as well. Here checkbox on as well. And here we don't need our formats, but you can have, like, if you want to get schema from this table, then you can choose this as well. And this way you just create your data sets, second data sets, which is a sync related. And that's it. And I want to show you folder. So you can create your folder by clicking here. You can give a suitable name and you create it. So it will appear here. And then you can move your links, the data set, by just selecting and right click, and you can use move, and you select this folder. That's it. So it will move there. So as Ben said, is that once you do one by one pipeline development, it's huge, big set you will see that. So better to organize based on a folder structure for a specific purpose.
Okay, then let me show you how to create those data sets using Bicep code.
Yeah, absolutely.
So I'll start sharing my screen. So now we have created the linked services using Bicep code, and next thing we want to do is create data sets. And that's, again, follows the same schematic that you've already seen in Bicep. And that's a nice thing about Bicep. Once you've understood the schematic of it, it's very easy to write. Again, we declare a resource, we give the resource a name, and it's of type data factory. Factory is data sets, because we want to create a data set. It has a name, and that's the dataset blob file name. That's what I called my variable. It depends on the data factory and the linked service to the storage account. And now I can set the properties that Alpa just showed you. I say, okay, this is delimited text, so CSV. I set the linked service. I say linked service reference, and I give the reference name of the linked service. And I can set my type properties. I can do all the things that Alpa just showed. I say the location, where is my file located? It's in a blob storage location. It's called movies.csv, and it's in the container file in. So that way I can easily add the location. I could also add a folder path here if it was in a folder structure. So then next I can set all those parameters that Alpa showed you in the UI. I can set a column delimiter, escape characters. I can tell it that the first rows are headers. I can set a quote character. And I can manually set the schema if this is required. So the schema, I can tell Data Factory when I deploy this. I have a column that is called movie and is of type string, called title is of type string, called genres is of type string, and so on and so forth. And for the sync data set, basically it's again the same thing. I define my data set, Data Factory's data sets. I give it a name. It depends on the linked service for the database. And the properties is it's of type Azure SQL table. I reference my linked service here. And the properties I set is I just set the schema and the table. I don't set so the database schema and the table name, and I don't set the metadata, the schema. I don't need that because, as Alpa just mentioned, we want to use this as sync, so we don't need to set the schema here. And that way, with just a few lines of code, I have created the two. I'm able to create the two data sets that Alpa just showed you. And now, to use those data sets, Alpa, please continue with your pipelines.
Yeah, okay. So here now we're going to create pipelines, and then pipeline can have activities as well. I'm just discarding these things. So for creating a pipeline, this is a pipeline section. So you can create pipeline by just clicking here. And again, you can create folders here as well. And you can create pipeline from existence template as well. So these are the all existence template. If you like to do your POC, then you just select select this way, and you create a link service if you don't have it. That's it. So you create here two link service, and then when you let me select if I don't have it. So but yeah, so you create a link service of this kind of I think it's Data Lake Gen 2 or something. Yeah, Synapse Analytics. So you create two link services, and then once you click here, it will pipeline will appear into your pipeline area in here. Automatically you will see that. Or you can create manually as well. So by just clicking here, you can create pipeline here, or you can click here three dots. So two way you can create your pipeline. So let's create a new pipeline. So these are the all activities. You can see that here I saw there are a lot of activities available earlier I said. So you have a data movements activity, you have other Azure services, for example, Azure Function, Azure Databricks, Azure Machine Learning. So these are the services which you can use it in here. You can integrate easily your Azure Data Factory with other Azure services. And these
I think Alpa, the general section, yeah.
This I realized that this is a general section. So here you can see that these are the activities. You can have a parent-child pipeline. So for this is a child pipeline execution. You have SSIS, you have fail related and lookup activities, store procedure if you want to execute. You can write down your separate script, SQL sequence steps, statements as well for scripts. And you can use output of this activity to input of another activity. You can set variable, you can have a web activity as well, and so many things. And these are the iteration. So as I said earlier, you just need to drag and drop. So if you want to use for each loop, instead of writing a code in a few lines, here you just drag and drop, and you will add here another activities. Like if you want whichever task you want to do iterative way, you just add here. That's it. So same way you can add other activities as well. So these are the activities available. And let's start with our activities, which we are using copy activity, because we're moving our data from source to sync. And our source is blob storage. So we selecting here source. That's it. And we can see there are various formats also available. If in your blob storage you have a many CSV file, then if you want to use that, then you can use wildcard as well. You can use prefix as well, and you can use a list of file as well. This one is our sync. So our sync is Azure SQL data set, because we are going to load the data into SQL Server. And here you also have so many other properties, like you can have upsert, you can use a store procedure instead of table. And you can create on the fly table as well. You can write down here prescripts, like you want to truncate your table before insertion, then you can do, or you can do other things as well. And these are the things which is related to performance. If you have huge amount of data, then you need to set batch timeout as well as max concurrence as well, because there is a by default limit is 30 minutes. So let's keep this one. So we have set sink and source. You will see how easy it is. You set source, you set a sink, that's it. And you can debug your pipeline by just clicking here. So if I have SQL Server open, I think somewhere I have open where it is. This one. So at the moment you will see that unless is that copy activity finish very quickly. Yeah, my table was empty, but I think now I may have a data. So these are the data. It came from my CSV file from blob storage. And here you can see that it's finished. So execution has finished quickly as well. And here you can monitor as well. This icon will tell you what is your source and what is your sink. And here you can see that how long it took for queuing and how long it took for transformation. So these are the all metrics you can get it here as well. And this in and out arrow will show you what is your input parameters and what is your output parameters. So with that, I would like to hand over to Ben to show same in biceps.
Yeah. Yes, thank you. So most of you will have guessed by now that what we need to create is a resource. We give a name is of type data factory, factories, pipelines. Huge surprise, it has a name. It depends on the data factory and my two data sets. And then in the properties comes an array of activities. In our case, that array contains only one activity, the copy data activity. I give that a name. It's of type copy because it's a copy activity. And I set some properties. So I say, okay, the source is of type delimited text source, and I can set some settings for the storage. I could remove these, doesn't change anything. I just left them in so that you can see that you can set certain settings, for example, recursing through directories and stuff. And then I set a sink, that is an Azure SQL sink. With write behavior, you saw that in Alpa's demo. Insert, I can set whether I want to use the table lock. I can set the auto create table option. And I have a translator that tells me how types are converted between source and sink. I could, because these are all default settings, I could just leave them out. And then what I can do is I just set the inputs and I say, okay, my input is a reference name, and it's reference for the dataset for the blob file, and it's a dataset reference. And the output is again a reference that is by the name of the dataset for the SQL database, and it's again of type dataset reference. So that's all I need to do if I want to create this pipeline in my data factory. And now what I would like to do to sum this up, to finish this, is to show you how to deploy this Bicep script, because I think this is an important step and we should be able to do this right now and run this and then see what resources are created in our Azure environment. So I'm in PowerShell to deploy my Bicep template. So let me navigate to my desktop and I call here. This is the command I need. I say AZ deployment group. So AZ deployment says I want to create a deployment and I want to create it on a group level, so in a resource group. I reference the resource group here. This is the ADF Bicep resource group that Alpa was also working in. And I pass a Bicep a template file. And I set the parameter location to West Europe. And basically, that's all I need to do. If my parameter doesn't have a default value and I don't pass it here, which is recommended for passwords and usernames, you don't want them to show up in your PowerShell history, so you would skip those. Then, and if they don't have a default value, which they shouldn't, then Bicep will prompt you for those parameters when you deploy your template. So let me now deploy that template. And if I run my deployment, okay, and now my deployment ran, hooray! And you can see that I get an output of all the resources that were created, and that I can also see provisioning state succeeded, so my deployment succeeded, and all the resources are created. And now let's add to the big surprise here and go to the portal and refresh, and we should see another data factory and another key vault. And as I said, for the key vault, if I look at the access policies, an access policy for my data factory was automatically created. And if I go to the data factory, then to my new data factory, then you will see, and once my data factory is loaded and I've scaled the font size to something that's readable in the presentation, you can see that my linked services are here. I can test the connection on those linked services, and the test connection will succeed on all of these linked services. And I also have here my data sets for the blob storage and for the SQL database. And I have here my pipeline that looks just like the pipeline Alpa showed you, with the copy activity that uses a storage data set from the blob storage as source, and a data set from the SQL database as sink with insert option, and I would be able to run that now to get the same result that Alpa did when she ran her pipeline. So to sum that up, Alpa, I would say, if we want to sum that up, we both agree that Data Factory is a cool tool.
Yes, yeah.
I think we both agree that writing Bicep code is not if you want to create a big data warehousing environment, because then dragging and dropping and creating hundreds of pipelines is much easier.
Yeah, of course.
But I think we can also agree that if you have a data factory with some pipelines, even if it's hundreds that are very similar, that you want to deploy throughout several stages or several locations that are the same everywhere because they're used in some process in your application, then using a Bicep template to create your data factory is a very cool way to automate the creation of data factory resources.
Yes, of course. Yeah. But if you are new to Azure Data Factory and you don't know much about JSON and Biceps, those kind of programming language, then I think best to use Azure Data Factory and drag and drop.
Of course. This is not the entry level option to create your resources using infrastructure as code.
Yeah.
Okay, so I would say, Alpa, it's time for us to say thank you for your attention.
Yeah, thank you all.
And thank you, Alpa, for giving this presentation with me.
Yeah, thank you. And I think we would like to thank you for our sponsor as well, because so with that, we would like to thanks to our sponsors, because without their help, this event won't be possible. So thank you all, and thank you attendees as well, and organization, bank, and everyone. Thank you.